Hi, this is Vipin Raghavan. I'm the founder and CEO at Haber.
1 मिनट रुक जाओ, रेडी होने दो। चलो ये कर लेते हैं। दिस कुड बी अ ग्रेट इंट्रो।
Hi, I'm Akshay.
Hi, this is Saurabh, and you are listening to the Founder Thesis podcast. We meet some of the most celebrated startup founders in the country.
And we want to learn how to build a unicorn.
It is much harder to build atoms than to build pixels. Or, in other words, manufacturing physical goods is harder than making software. We've been running factories for over a century, because of which it is seen as a slow-moving space. But the advent of new age technologies like IoT devices, sensors, and machine learning has the potential to disrupt traditional manufacturing practices and make factories more efficient, safe, and environment-friendly. This is exactly the insight that led Vipin Raghavan to start Haber. Vipin is an unlikely founder. He worked in the finance function for most of his career, but got bitten by the entrepreneurial bug when he joined Zynga, the gaming company. In his last job, he was visiting large plants across the country, where he saw firsthand the immense need for modernization in Indian factories. And the rest, as they say, is history. Here's Vipin telling Akshay Dutt about the journey of building Haber.
It was a group of us from Zynga that started Haber. Even though in between I had this other company, Ecolab. So Priya, who's now our chief operating officer, and Prashun, who was our chief technology officer. So three of us knew each other from Zynga. And then
The other two were also in Zynga India.
yeah, all three of us were in Zynga. Yep. So Zynga is kind of where a lot of the foundation was set. So we used to have these conversations over coffee or beers about interesting product ideas. How do we disrupt this or that? So everything from online grocery stores to robots to new gaming companies to whatnot. So, but me, Priya, we also wanted to do something that had a positive impact on society, not just, okay, we can build this very large company by disrupting this market. That was one piece of it, but we also wanted to do that in a space where we were having some kind of positive impact. So that was kind of the common thread between the three of us. Not to say that we had halos around our heads or anything like that, but we wanted to do something meaningful. So that's how the team kind of came together. So what we wanted out of our startup was something similar. So, and then going back to Ecolab, I went to one of these very large, well-known steel plants in India, and they would have one fatality every year. And they were proud of that. They were like, we're very good at safety. We only have one fatality every year. I'm like, are you effing kidding me? One person dies because they came to work for you every year and you're okay with that. And then this is something that, having better technology could solve. And it was not that they didn't want to do it. Those solutions were not even available. So everything from safety to environment to improving productivity, doing more with less, starting out with the same amount of raw materials and producing no finished product, or doing the same operation with less labor, or machines not breaking down, reducing your maintenance costs. So there was tons of just immense opportunity. Even you need 10 acres to build this plant. No, you don't. You can be more efficient. You can build it on an acre. So any one of those spaces, right, you could touch and you can disrupt.
Essentially, you wanted to bring Silicon Valley style disruption to heavy industry sector in India.
Yes. And going and visiting these plants, which I think the reason that you don't see more startups in the space is because of that, right? You don't get to go to these places. They won't even let you in. You have to be there for a reason. You can show up at the gates. You can't get past the gate. To get a gate pass to these places itself is hard. Plus, they are in the middle of nowhere. It's not like, okay, you're on your evening stroll and you're going to walk past a steel plant. That's never going to happen. So you have to deliberately go there. And then somebody has to let you in. And post that, these are these massive complexes. If somebody doesn't exactly show you around, you're still not going to know where to go, what to look at. So it's huge barrier to entry for that reason. And we saw this opportunity, and we were all very excited about specifically having an impact on energy and water use, right? So we quickly discovered that these factories use more energy than all the cars on the road, or all the homes use more water than all the humans put together. So this is where most of our resources are going, and not in cars and in homes and whatnot. And so if you could even make a small change here, you're going to make massive impact at a macro scale.
So, what did you want to do? Did you first get like a pilot customer and then figure out with them what you want to build?
We were like, okay, whatever we did had to have scale. And we saw this problem of energy and water use. So there was one problem which was around safety. So remember, we also wanted to do something with a positive impact, not just helping these factories make more money. So we're like, okay, we can help their employees be in a safer environment, or we can help these companies use less water, use less energy, take out CO2 from the atmosphere, do that kind of. And we decided to narrow down on that space, the saving of energy and water, because that also had a P&L impact, because it was costing them. If we saved a guy from losing one of his fingers, maybe that didn't translate to so much value for the company. So safety is another space that should get disrupted, in my opinion, and there should be a way to translate that into commercial value. So we didn't go down the safety route. We went down the route of saving water and energy, because it was also attractive to these companies, not so much to the Indian companies. So we went from, okay, this is the problem we want to solve. The product that we build to solve this problem should have scale, right? We don't want to build custom products. We want to build one product which can be plugged into as many places as possible. So we started studying their processes. What we saw was there was this area where the way they control different aspects of the plant, they would collect like a sample of their slurry in a beaker, walk it over to an on-site lab, do a bunch of measurements with benchtop instruments, and then a human subject matter expert would look at this data, and then they would determine how to tweak their process to take corrective action, because from whatever readings they got. So we said, hey, can we build something to automate this loop, and by more efficient control of the process, help these factories consume less power, consume less water. So we built a product called ELIXA, ELIXA, and it stands for Electronic Live Information Exchange and Analysis. So what it basically does is the whole sampling process, it is automated. Basically, think of it as a small robot doing the action of collecting and measuring. And then that data gets applied to an algorithm, which is inside of our product. And then the algorithm takes decisions as to whether to switch on and off a valve, or turn a pump on and off, or make a pump go faster or slower. So that's a loop that we have automated with ELIXA, our flagship, our product.
So help me understand who is this manufacturer? What is this slurry thing? That is what is the problem that they're facing, which ELIXA is solving?
So think of you're ordering coffee from Starbucks or Caribou or wherever. You get your coffee in the paper cup. It's called cup stock. Now that is made from wood. So they're not going and chopping down forests. So there is wood grown as an agricultural crop. So there are farmers who grow wood, and then that wood gets converted into pulp. You get this brownish kind of wood, and it gets turned into kind of whitish kind of pulp. And then that pulp gets converted into paper stock that then becomes the cups. And then those are the cups that we get at Starbucks. Now, in that process, right, the pulp gets carried through different stages of the manufacturing process before it finally becomes the cup stock. So what we are sampling is that pulp, right? So pulp is nothing but 99% water and 1% wood fiber. So that's what we are sampling at different stages of the manufacturing process and measuring for, think of it as converting brown pulp to white pulp, and then a white pulp which is not as strong to a bit more stronger kind of white pulp. So each stage has a purpose. And what ELIXA is doing is, okay, in the conversion of this brown pulp to white pulp, it's sampling both of these and then saying, okay, how do I consume as little resources in that process? So in terms of how much steam gets added, how much chemicals get added, can that be done with less steam, less chemicals, and still get the same whitish kind of pulp, right? So that's why our customers are subscribing to ELIXA, because they get savings in the form of steam equals energy savings. Or they're consuming less chemicals in the process. So
okay. So the traditional approach was manual tweaking, like someone would come do a test.
Yeah, somebody would grab a sample of the brown pulp and the white pulp maybe once every hour. So they're not getting continuous data. They don't know what's happening in between. They just assume that there's no change in between. So they collect the sample, they walk it over, and these are usually massive complexes. So they walk it over to an on-site lab. That takes time. The sample collection takes time. Taking it to the lab and measuring takes time. The analysis takes time, and it's dependent on human subject matter experts who are extremely rare. These are not industries where we are sending a lot of talent to anymore, right? So this talent that they have is extremely rare as well, right? So the people who can look at this data and make sense of it and then determine if they had to tweak something, add more steam or reduce the amount of steam or whatever the corrective action they had to take. So as you can imagine, no continuous data, any kind of analysis is delayed. By the time they figure out that they need to take corrective action, they've missed the opportunity to take corrective action at the right time. They end up consuming more steam, or they end up making pulp that is not as white, so they have to kind of throw it away and make new pulp, because Starbucks is not going to accept, because you want your cups to look exactly the same every time, because they got to print the green Starbucks logos on them. So if the cup is kind of brownish and you print the green logo, it's not going to look like the green logo anymore. So for all those reasons, they need consistent quality kind of manufacturing, and as well, and also controlling the resources that are getting consumed in that process. So that's one example of where we plug in an Elixir.
What all industries would be covered by this? So essentially, these are any industry which has a process in which there is water involved, like you talked of paper.
Yeah, no, not necessarily. So we focus on what we call process manufacturing, right? So these are continuous 24/7, 365-day plans, as opposed to discrete manufacturing. So if you think about putting a car together, that's discrete manufacturing, right? So these are process industries, which you have raw material kind of continuously flowing through a process and the finished good coming out of the other side, which is also continuous and not a unit like a car. It's a roll of steel or it's a roll of paper or whatever it is, right? So those are the industries. So anything metals, right? Steel, alumina, things like that. Pulp and packaging. So think about everything from your tissue to the boxes that you're getting your Amazon deliveries to your Starbucks cups, that industry. Food and beverage processing. So sugar, breweries, dairy, right? All of it. So those are the industries that we are currently focused on. So oil and gas would be another space where we could apply Elixir. We're not looking at oil and gas.
How do you get the data real time? Like this would essentially need you to build a device which can test real time. And
so just like our phone has sensors in it, so Elixir's got its own sensors. So the sample is flowing through like a flow cell with a few sensors. So which is why I was calling it a Fitbit for factory. So it's measuring these critical parameters in real time, and then the sample just goes back into the processor. So it's continuously sampling, and there are sensors which are measuring critical parameters, and that's the data that's getting applied to the algorithm.
yeah, so like you need to build it separately for each industry, or what are those sensors doing? Like help me understand the tech behind it. Like would a set of sensors that work in food and beverage also work in pulp, also work in oil and gas, also work in metals? Like
for the most part, yes, because the parameters that we're interested in are kind of similar, right? Obviously, they're very different industries, but temperature is important. pH is basically something that tells you whether it's acidic or basic. pH is extremely important. There are other things called conductivity, alkalinity. So these are the same. So you're still concerned about the same things. And then there's like an optical sensor that's basically shooting out light at different wavelengths, and it studies the light bounces off the particles and comes back, and then we can study different things. So for the most part, 90%, the sensors are the same. There are some unique sensors required for some unique applications. So, but for the most part, it's the same, right?
So temperature, pH, optical, these are like the three mainstream sensors, which are like 90% of the cases are covered by these.
Yep. And then there is flexibility. So when I say pH, it's like an electrochemical sensor. It tells you multiple things. It tells you pH, ORP, conductivity, many things. And then the optical sensor also. So a lot of things that you measure are through optics. You're just shooting out light at different wavelengths, and
like the color is appropriate or not. And
a lot more than just color. So even, the tests that you do for coronavirus and all, those are also optics. You're adding a reagent and then looking at how much sort of the color changes. And that's what you're getting. So optical sensors, how most of the world works.
Okay. Like just to get a little more nerdy, like give me through an example that it could be like say a juice or a pulp or whatever, that through pH sensor, we can figure out if this is going wrong or not, and or through the optical sensor, like a little more.
Yeah, sure. Go back to that example of making the pulp for the cups. So you're starting out with wood, right? So there's variability in that. It's a natural resource, right? So inherently you have some variability. So you're starting with some kind of variation, right? And then you're adding heat, you're adding pH shock, and that's how you get the tannins and things like that out, and you get what you want, which is whitish kind of pulp. So
pH shock is what, like through some chemicals?
oh yeah, you're giving extreme pH. So you're taking it down to very, very acidic pH and then taking it up to very high pH. So when you give it pH shock, the things that are kind of not so well chemically bonded, those things tend to kind of loosen out, right? So if you think about soap has a little bit of pH shock. So you get the dirt out, right? You have the foaming, and then you have a little bit of pH shock, which is what gets your dirt out. So pH shock kind of basically separate. It can destroy things as well, but you can kind of separate things, right? So in the case of wood, you have cellulose and you have tannins and things like that. So you want to remove these tannins and you want to retain just the cellulose. So the fiber is what gives it the strength, right? So if you have tissue, you get the strength. So this is just the fiber, which is cellulose and hemicellulose, without getting into too much of the chemistry. So basically, the way you're doing it is by adding heat and then moving the pH up and down, and then some other things as well. And then what comes out is the pulp that you desire, that you want to make the cups with. So because you're starting out with wood chips that are introducing variability, right? So you have some level of variation always happening in the process, right?
Yeah. The input is not standardized because it's a natural product.
Yep. And you're starting out with wood chips, and also you're adding water to it. The water also comes with some amount of variation, right? So wood plus water becomes your pulp, and then you're decreasing the temperature, so on and so forth. So because you're starting with this natural resource, you inherently have some variation. What Elixir is doing is predicting what the pulp that's going to come out the other side is. How white is it going to be? How strong is it going to be? How much cellulose it's going to have? All the desirable characters, and then figuring out, okay, if something is expected to go out, let's say Elixir is expecting brightness to go down, right? Below a certain threshold. Let's say there's a minimum threshold of brightness and you don't want it to go below that. And it's predicting that an hour from now, that's going to happen. So what Elixir is doing, predicting something in the future, and then it's taking an action right now, a corrective action right now to prevent that bad thing that might happen in the future. So we're giving it the controls to move the levers, right? So it's then increasing the steam or reducing the acids or whatever it has to do to then meet that. And also so that's one thing that we ask it to do. The second thing we're asking it to do is get me consistent brightness by using as little steam and as little chemicals as possible. So it's giving you consistent brightness, but it's also doing it with the least amount of resources.
Essentially, it's like highly fine-tuned.
With very simplified fashion, yeah, that's what it's doing. Think of it as like an autonomous driving car, but it's sort of predicting what's going to happen with traffic or by looking at things in the present and what it's seen in the past. So it's going to be like, okay, down the road, I'm expecting this guy to cross the street. So I'm going to start decelerating right now so that I don't have to slam on the brakes when I get there. So that type of thing.
So how did you learn what these numbers would mean? So you had a device which was throwing out numbers based on these sensors, like some temperature numbers, some pH numbers, some numbers which would come from the optical sensor. How did you figure out what these numbers would mean, what they would predict? How did you build the intelligence?
Sure. So I also have this AI background. Okay. So going back to my engineering, one of the electives that I took in the final year was AI and neural networks. Back in those days, there was no application for it. It was mostly just theory. So I was very intrigued with how AI works. And fast forward to my MBA, the reason I got into that startup was also I participated in this business plan competition. And my business plan was called mdnetwork.com. Okay. And what the idea was, a neural network that physicians would subscribe to. And they would have their patients come in and put in all their symptoms, and this neural network gets smarter and smarter over time, and then become smarter than physicians and can then predict very accurately the disease state with the symptoms fed in. So that was the business idea. And John Papajohn, not the pizza guy, but the VC guy, offered to write me a check if I drop out and actually start this business. And I didn't. At that time, I wasn't sure what he was even talking about. I was like, "What the hell are you talking about? I'm here to get my MBA."
That was before dropping out was cool.
Yeah, exactly. And I didn't have in my family, in my friends network, I didn't have the right kind of support or people to guide me. I didn't know what the hell this guy was talking about. And I said, I'll think about it. But I said I was just there for the business plan competition. So I won the business plan competition and got like this opportunity to go work at a startup. So that was also an AI based, even before there was applications for AI. So the idea was an AI based medical diagnosis tool. So in addition to having this entrepreneurial itch, I also had this AI itch. And so fast forward to Haber. So I was looking for AI to solve the problem of not having sufficient human experts available, and also the speed at which human experts can perform. So that was the other problem that we were solving. So the way Elixir also works is, you don't need to necessarily measure everything. So if I know, for example, if I know the angle of sunlight, I can probably tell you with a high degree of accuracy what the temperature is without having to measure temperature directly. So we figured out virtual sensors, right? So there are a lot of things that Elixir can predict, which it's not directly measuring with a high degree of accuracy. So the AI is the secret sauce behind the product. We did solve a bunch of other things, but kind of making that human subject matter expert obsolete is the biggest value that we are adding. And although I don't want to use the word obsolete, let's say augment, making that human subject matter expert available to every factory all the time, which in the past, they would literally, I mean, even today this happens because we haven't taken over the market. We still have a very small piece of the market. People would just fly in. So you would have like an expert in Japan, and there's only 5 of those experts globally. So this guy would take a flight from Tokyo to Delhi and literally parachute into a plant and look at this data and solve it. And why can't they do it remotely? It's very hard for a human to just look at data on a spreadsheet, and they would want to come visually see, and not just through video. They would want to get a feel for it. And this is how they solve some of these.
Yeah, it's an investigative process.
Exactly. Yep. And these people are extremely rare, and they're getting rarer by the day. So unless industry puts a lot of these things in software, they're going to have a hard time even existing a few years from now.
So you would actually be getting data from multiple stages in the whole process. And also you would need data at the end that this is meeting desired standards. Because that is how the AI will get trained. If it sees input data and then it sees output data.
So now we are plugging Elixirs into small sub processes within the plant, right? We haven't put an Elixir that controls the entire plant into it. So if you think about plant, it's just sub plants within a plant. There's multiple sequences of processes, right? Some in series, some in parallel. And so we plug in Elixir into those discrete processes. And it's just figuring out what is this process meant for? What is it doing? There's a goal for the process, right? So we're giving Elixir some goals, right? The way Elixir sees it is, it's a bunch of time series data points because everything is just moving in time, some of which it can control, a lot of which it cannot control, and some of it which are desired parameters. Like, for example, I want brightness to be as stable as possible. And then it's just predicting brightness. It knows what brightness is right now. It doesn't know what brightness is in the future. It's predicting it. And then saying, okay, if brightness is going to drop below a certain threshold or is going to be too bright, how do I get it back within that range? By these 3 levers that I have right now. I only have these 3 levers. So how do I tweak these 3 levers so that I get that? So it's just working in that sub process and so on and so forth. So the next level of this stuff is then a little project we are working off to the side, which is kind of building this digital twin of the entire factory and having Elixirs talk to each other and telling each other what to do. Right now, we're just using data from different Elixirs to kind of strengthen the algorithm. They're not necessarily they're sharing data. They're not talking to each other and telling each other what to do. So that's like the next stage of it. And that will enable a lot more. And now think about this. Let's say this manufacturing plant has 5 stages, right? So we are individually optimizing each of these 5 stages. Now imagine if all 5 Elixirs are talking to each other. You could take it to the next level. Maybe you don't need to make it as bright in stage 1. You can make up for it in stage 2, or you can make up for it in stage 5. And then we can figure out the most optimized way of doing it across as opposed to like in individual stages.
Okay. So right now, like a stage 1 Elixir and a stage 5 Elixir, their data would build the algorithm, because you can see that in stage 1, if temperature is off by 5 degrees, then in stage 5, brightness goes down. Like I'm highly simplifying it, but
Absolutely.
Yeah.
And we're doing some of this offline, right? Because we have Elixirs live in certain plants where the sequences are in parallel. And we are doing this offline, meaning we have our subject matter experts looking at this and be like, oh, here's an insight. So, and then taking that back to the customer and tweaking the goals. So now instead of taking it to 60 brightness in stage 1, let's only take it to 55 and then adjust it in stage 3, that type of thing. But that's happening offline. It's not happening in the true AI sense. So that is something that we are currently working on, because again, you got to be able to scale these things. How do you build a digital twin of any factory in a way that things are configurable? These mathematical operators, AI operators can kind of work together in harmony. It's a complicated problem. We are solving it, and we have a great team to solve it. Yeah, once we take the product to that level, it's going to be amazingly effective, right?
I'm guessing that the evolution must have been like this. The initial product would have been one in which those sensors are giving real-time data, and there is some hard-coded rules that in this stage, temperature should be within this range, pH should be in this range, or whatever tests are coming out. There would have been some hard-coded information that, okay, these are the ranges to maintain. If there is deviation, then press this lever or do this action.
So yeah, at first, our first POC was a combination of a subject matter expert-based algorithm, plus fuzzy. So, and then it would test which was better. Was fuzzy better, or the SME algorithm was better, and we would just use that. So there was like this decision tree. And
But how did you build fuzzy right in the beginning? Because you probably wouldn't have had enough data to build fuzzy. Like what? Tell me about that. Like, what does that mean, fuzzy?
we built a generic fuzzy, right? It wasn't like specific to the problem. We just had a generic fuzzy algorithm.
What does that mean? What is a fuzzy algorithm?
Fuzzy means, okay, I have this lever. Let me start by going to the extremes of this lever, as high as possible, as low as possible, see the impact of it, and then kind of strengthen the algorithm over time. And not necessarily like a time series AI model that will understand seasonality and times of the day and different things like that. So fuzzy is more, think of it as running random experiments, and then just strengthening that and figuring out, okay, between these parameters, I have these kind of strengths. So that was how we started out, coupled with a subject matter expert algorithm, and then kind of a decision tree, which would say, okay, which one can predict better, and it would just use that to control, right?
So your customer allowed you to like run like these white.
See, because we were giving them a much superior product. We were giving them real-time data, which was visible to me. At that time, we hadn't yet built our online dashboards yet. So there's a screen. So Elixir is this device that's about the size of a small refrigerator. So that's how big the device is. It has a screen also. So they could even go at the screen and look at the data. I mean, day one, obviously, even that did not exist. It was just seeing data on a terminal. So then we had the screen. So they could see what was happening. That itself was a step above. And secondly, there was some kind of action being taken, right? Now, the concern was how good was this action, right? But then this action was controlled by how much of a change could Elixir make. So that was also controlled. You can only move from between 40 and 50. You can't take it down to 20, or you can't take it down up to 100. So you can only go between 40 and 50. So that gave the customer enough comfort that, okay, you can't mess things up too bad. So we started out with very tight guardrails that gave customer. We had an early adopter, Padamji, which is a company here in Pune that makes some of these filtration products that then 3M uses. Everything from your masks to filters that go in cars. They also make hygiene products, so the paper that goes in diapers, tissue paper, those kinds of things. Right? So it's
like a fabric company, basically.
It's a pulp and paper company. But the end use of these paper products is filtration, hygiene, things like that. So in their pulp mill, where they make the pulp, is where we applied Elixir. That was the first use case of Elixir. And in parallel, we went live at Imami. Imami is a large consumer company. And Imami is also one of India's largest packaging producers. They the boxes that the Fair and Handsome comes in. They make those in-house, and then they sell those the packaging for other people to put their products in boxes. So these were our two early adopters, and they were keen on applying technology in their factories. They gave us our first break, and yeah, from there was no looking back. So those installations still existed to this date, right? So these are installations that go back to 2017. So it's almost been 5 years. So those installations are still there. We've changed the hardware as with newer generations of hardware. But those installations and what they're doing, still they're doing that, right? Which is predicting, controlling, saving both Padamji and Imami lots of energy, water, more consistent. In the case of Padamji, more consistent quality pulp. In the case of Imami, it is kind of like in their power plant. So their power plant is using less coal. It's a massive savings there, right?
Can you talk about the evolution journey of the hardware? Like currently you're saying it's like a refrigerator size box. So what did it start with and how did it get to where it is today? What did you learn along the way, or what mistakes did you make along the way?
Yes. So fundamentally, the hardware, the components have not changed a whole lot, right? It's got like 3 sections, right? The top section behind the screen is the brain, the processor, memory, the IO cards and whatnot. The middle section is kind of hard electrical stuff to talk to different components in the factory, because not everything in the factory is a smart device. So taking like an electronic signal and converting that into an electric signal. So there's like a piece in the middle that does that. And the bottom third is the sensor array. So it's like a little flow cell. Think of it as a cylindrical tube where the slurry is passing through and sensors mounted in there. So that also, I mean, obviously the iterations are just making it better, more efficient, using less sample, less cleaning cycles, more efficient cleaning cycles. Those are the iterations that we've gone through. But in the top, the brain itself, right? Our latest generation, which is what we call Elixir 4, it's much smarter. It can run heavy AI models on it. Things that we were earlier running on the cloud and we would push down pickle files. Now those things can happen in the edge itself. It has more memory, right? So it keeps more data, which also helps with some of the AI functionalities, and security. So security is a big piece that we have enhanced quite a bit. So now we have security in the hardware itself, right? So Elixir 4 is impenetrable, right? So we're going to run a hackathon, as soon as we didn't want to run an online hackathon. So I think now that things are starting to open up here in India, we want to run like a hackathon where we put a Elixir in the middle of the room and anybody who can hack into it gets like a $10,000 prize. So security is something that we have significantly improved with the latest generation and things like, so having stronger processor memory, now we can do computer vision. So computer vision was Elixir 3, and prior to that, we couldn't do computer vision.
So you mean like the optical sensor?
No, optical sensors is just shooting out light and then measuring different energies. That's very small data. I'm talking about high quality video.
Camera.
Yep. So taking optics to the next level, basically. So with video data, you can do a lot more. So we haven't rolled out any computer vision based use cases yet, but yes, so that's something that we want to do.
And is this like, how do you build this? Like, how did you figure out building this? Did you find suppliers in India? Did you have to go to China and figure it out?
Yeah. So when we were building Elixir, the architecture, right, back in 2016, there was no edge computing device there was no edge computing device off the shelf that one could buy. So we built the entire electronic architecture from scratch. So what is it that we want to do? Selected a processor, selected the memory. We also did like analog to digital conversion, digital to analog conversion. So there's a lot of electronic architecture that went behind it. And then electronics are just devices, little chips, and you got to make them alive. So porting the operating system, the embedded software layer, all that architecture was built in-house. And the key thing is these are 24/7, 365 day. Our product has to work. It can never break. So that was the hardest problem to solve, because what happens is you get memory overload, you get processing overload, or things heat up and it breaks. And it used to happen in the beginning. We would have to.
I guess Alexa 1 must be like hand assembled kind of or close to that, like.
Yeah, so we didn't print the boards. Yeah, we kind of etched the boards at a local supplier, and then we just hand soldered the parts. But very quickly we went to kind of robotic board building, soldering, etching, and all that, because that was another reason why things could fail, because you can't solder manually. Soldering is very hard, and we used to do it, right? I myself used to sit in our homes and be doing this stuff, right? And we didn't have the best equipment also. But so the electronics got solved in terms of the quality of building the electronics. That we fixed very quickly once we went to automated building of boards. The software, kind of the hanging of the software, you can just think, going back even a few years, how frequently would your cell phone crash? Even the good ones. So we had to solve for that. Our device could never crash. So that was a very hard problem to solve that we solved. So obviously today Elixir's never crash.
Did you build your own operating system? Or?
So it runs on Linux, and then we ported Linux, and the embedded layer is all in C. So meaning moving the code and managing memory, all that is done with C. We wrote the code in C. Yeah. So like I said, you gotta use memory in an efficient fashion. And back into it, the things have kind of advanced since then, right? Back then, getting 2 GB memory or 6 GB or whatever was not easy on a board. And it was prohibitively expensive, because you got to think about how much the box is going to cost as well. Memory and processing have become cheaper over the last few years, which is what is enabling us to do like a computer vision and things like that. So yeah, solving the embedded layer, I would say more than the AI, that was the really hard engineering problem that obviously you don't get a lot of credit for doing that, because nobody sees it. Oh, your product never fails. Good, because that's what you expect. You should never fail. So it does what is expected.
How does it manipulate the levers? Like you said, that it can control, like say, steam or water and all of those. So how does that happen?
Yeah, so it's a two-stage process, right? So the first stage is predicting, right? So it's predicting what brightness is going to be sometime in the future. Then it is think of it as, let's say there were only 3 parameters, right? So it's looking at like this cube that has 3 parameters, and then it's finding the right spot inside that cube, which will then solve for the brightness problem. But it's not a nice 3-dimensional cube. It's this multi-dimensional thing which we cannot comprehend. So it's looking at this multi-dimensional space and finding that right intersection of all the parameters. And actually, it sometimes would find maybe 2 different solutions that can, and then it has to choose which one to go for. So that's what it's essentially doing. So the first stage of the algorithm is predicting, right? What is brightness going to be 90 minutes from now? So it's time series data is like a movie, right? So every frame has some dependency on the previous frame and what happened previously, and so on and so forth. So if you know what has happened up until now, and you've seen these patterns previously, so if you're watching Game of Thrones, and you've seen like the first season, you can kind of predict what's going to happen in episode 4 in season 2, right?
It's what people do in equity also, like that technical analysis. So based on how that stock price has moved over time, you kind of try and predict.
Yeah. The technical analysis is, now the models are more, combination of fundamental and technical, which is where AI can do a better job. So what it's doing is it's watching this movie, and it's seen this movie many times before, and not just in this theater, it's watched this movie in other theaters. So remember, the data is getting shared on the cloud from different Elixirs. So it's finding common patterns between those. And then it's saying, okay, I've seen all the stuff. I want to predict what's going to happen in the future. It's predicting that. And if that prediction is not a desired outcome, then it's saying, what can I change right now? How do I change the plot right now to get my desired outcome in the future? And that changing the plot is, let's say some processes might have 10 parameters to as many as 100 parameters, right? So it's looking at this thing in 10 different dimensions, 100 different dimensions, and finding the combination. So some things it cannot control, right? So out of those 100 things, let's say it cannot control 88 things. It can only control 12 things. So those 88 things are given to it. And then it's saying, okay, these 12 things that I can change, how do I change it so that the professor doesn't get caught in Money Heist in the next episode? If you're a fan of Money Heist.
If you like to hear stories of founders, then we have tons of great stories from entrepreneurs who have built billion-dollar businesses. Just search for the Founder Thesis podcast on any audio streaming app like Spotify, Gaana, Apple Podcasts, and subscribe to the show.
But how does it change? Like, does it need to do some physical manipulation?
Well, how does it then talk to the plant? Yeah, so the plant is running on its own systems, right? The plant, so there are these things called DCS, distributed control systems, or SCADA, supervisory control, or data acquisition system. So these are, you might have seen them in movies, in like nuclear plants or in NASA control rooms, a bunch of screens and a bunch of people just staring at these screens. So you go to any plant, you're going to find, they don't call it a control room, but it's kind of like a control room. They would call it like a DCS room or a SCADA room. People like to hang out there because it's air conditioned, and you'd find these people looking at. So that's where they control their plants from. So then Elixir is talking back to the DCS, right? And sending. So the other thing that we've solved for is this protocol conversion, right? Because different DCSs, SCADAs talk different languages. TCP/IP, Modbus, Profibus, Profinet, whatever. So it's translating into whatever protocol that DCS understands, the language, and then it's sending those instructions. One, change it from 50 liters per hour to 48 liters per hour. That'll be the instruction that it tells the DCS. And then the DCS will control the pump, right? Which previously would have been this guy sitting in a DCS room and entering data into like a little text box, or in slightly more primitive plants, literally somebody walking to that pump and turning a knob. And even in more advanced plants, you might see things there where you have to send somebody to a pump or a valve, and they might have to manually control the valve or the pump.
But so Alexa can only work if the plant has a DCS/SCADA. This manual kind of plants, like.
Yeah, so that's that middle section of Elixir, right? Let's say the plant is not very advanced. It cannot understand digital. It's not a digital plant, or certain parts of the plant are not digital, are still analog. So that's where it's taking the middle section, converts the digital signal into an electrical signal. So it's mostly what is called a 4 to 20 milliampere current loop. So you adjust the current between 4 and 20, and depending on what the device does, let's say it's a pump that moves between 20 liters and 200 liters. So 4 corresponds to 20, and then 20 corresponds to 200. So it will send like a 4 to 20 milliampere signal, and then basically control the power that's going to the pump, and then that translates to the speed of the pump. So we have customers who are not just enterprise, more stable, more advanced plants. So interestingly, India has some of the most advanced plants. Because it has some of the newest plants, the newest investments in the world. And it also has some of the oldest crap, right? Like stuff that is really low tech.
Built in the 50s.
I mean, maybe not built in the 50s, but some European plant that was going down wanted to sell it, and they would go and pick up this plant and build it over and then rebuild it here.
Well, I just want to clarify one quick thing before we talk. So, like you said, this 4 to 20 thing. So it's like when I have a mixie at home, then I can do 1, 2, 3, 4, and that the blade moves faster or slower based on what number I'm selecting. So this is the same thing happening directly from Alexa to the pump, like telling it what speed to pump at, like instead of those buttons getting pressed. That is what the 4 to 20 thing does.
Yes. So what's happening is there is something called a variable frequency drive. So that converts this electrical signal to the frequency, and then the frequency controls how fast this motor is spinning. So in your blade example, when you turn that knob 1, 2, 3, 4, it is changing the frequency and then how fast it's moving, right?
Yeah. So Alexa does this. Okay. What if there was a tap which needed to be turned? Is that?
Oh, so yeah, that's a good question. Well, what if there was a completely manual thing that doesn't even run on power? So we haven't solved for that yet. Do those things exist? Yes, there are some valves which are completely manual. They need to be opened with human physical endurance, like either turning the
Muscle power.
muscle power. So yeah, those things would need to be augmented before Alexa can talk to them.
But those are edge cases, I guess. They're not mainstream.
Yeah, those are not very common, right? Yeah, do those exist? Yeah, you could have a situation where you have something flowing and gravity being used for the force, and somebody might manually kind of open and close a valve. Have we seen those? Yes, we have, but those are not very common. Because these plans are tens to hundreds of millions of dollars of investment. So they have some minimum level of automation, minimum kind of modernization.
Okay. And how do you install this device? Like, what is the installation process for it?
Yeah. So just quickly talk about how we sell and then how we install. So how we sell is we send, there is now like some word of mouth, people coming to us and asking us, right? Which is how I want all of the selling to be.
And you're selling in India or like?
So yeah, we have customers in the subcontinent. So Bangladesh, Sri Lanka, India. Most of our customers are in India today. Also in the Middle East and Africa. And we just started selling in the US. We hired a sales head for the US market. And we've just started selling there, but we don't have any customers yet in the US. We just started the process. But yeah, this is where all our customers are today. So from Qatar to Oman to UAE to Kenya to Uganda to India to Sri Lanka, Bangladesh. And so how our team would go talk to somebody at the plant, like a decision maker, usually the plant manager, and then talk about a case study that we had already done in some other customer site. We just show them the case study and whatnot, and try to win the contract. So either they're doing something right now with some kind of inferior technology, or they're not doing anything at all. So either we are replacing a cost or we are a new cost. And then our new cost has to be justified by the ROI that Elixir is providing. So we say things like, okay, hypothetically, this is the kind of savings, this is the kind of impact. You're going to save so much energy, which translates to so many hundreds of thousands of dollars.
You would need an engineer in your pre-sales process who would actually study and then present a customized proposal.
Yeah. So we have a customer success team which does both the pre-sales bit and then the post-contract, the go-live process. But even our core sales guys are mostly have like a engineering technical background. So some of them can do it themselves. Sometimes they would take a member of the customer success team. It's a very small team. And our customer success team is they're the most experienced team in the organization. So they're very super experienced folks. So these guys would go in and they'd kind of calculate the savings, and they would say, okay, this is going to be the impact. We shoot out a proposal, turns to contract, and then we kick off our go live process. So we have a program management team who goes from contract to go live. They work with the customer success team, and within the program management team, we have our own installation team. So we have guys who will go to these plants and do the physical installation. We want to get to a state like IKEA where we could just send Elixir in a box with a manual to how to install it. We want to get there, but that's going to take some time. But, having enough installation engineers, it's not stopping us from growing. So it's not a problem, but we want to get to that spot.
This is a high impact purchase. So they would probably want an engineer from Haber to come in and make sure everything is installed properly.
And definitely in India, they wouldn't want it. The pandemic has allowed us to kind of go a little bit remote on that with minimum presence at the customer plant site and doing more explanation through video.
Like you can do troubleshooting remotely.
Right? Yeah. So that in a way, the pandemic helped us to make that paradigm shift. But yeah, we want to get it to a place where customers can just order Elixirs, open the box, configure it themselves, and build their own algorithm. So we're calling that project internally Mount Fuji. The reason I'm laughing is because you're in Japan. So that project internally is called Mount Fuji, which is, we are making Elixir more sandboxes. And so I borrowed a little bit from this product called Lego Mindstorm. I don't know if you've seen that.
Minecraft.
Lego Mindstorm. Yeah, Mindstorms. Like MINDSTORMS, Lego Mindstorms. So what Lego Mindstorms is, I bought this for my kid, right? So it's a box that comes with a bunch of generic sensors and a little cube, which is the processor. And you can, just like any other Lego thing, you can put these things together. You can make a car, you can make a walking robot. My son, what he built was something that can sketch by itself. So he stuck like a sketch pen to it, and it'll do its own. Obviously, they are more geometric kind of. They're not going to do like Picasso type of stuff. It'll do like its own geometric kind of sketches. So with a bunch of little things, you can build a variety of solutions. So we are taking Elixir down that path. So
essentially a platform approach, like the way, like say Salesforce, you can buy it for any kind of business, and then you can either customize it yourself or work with a partner who will customize it for you.
Yeah, that is our Mount Fuji. Yep.
Okay. Why Mount Fuji?
So earlier, my project names came with names like Orca, Barracuda, things that are aggressive, and so I wanted to go with something a bit more positive, right? In a mountain, positivity, scaling the mountain, getting to the top type of,
How does the communication happen? Like, how does it send data to the cloud? Is there like
Yeah.
a 3G?
Right now we are hosting all the data on Azure and AWS. We're using the two biggest cloud platforms, so the data is hosted there. And
Or is it like a 3G SIM inside Alexa, or like how does it talk? How does the data get?
yeah, but there is a SIM card in India, especially. Our timing was just about perfect. So Geo launching in India and when we launched Alexa was almost at the same time. So there were a lot of places in India where you could not get a cell phone signal, especially where these plans were located. And when we were doing some of our early prototypes, that was one of the challenges. So we had to rely on the plant's network to send the data and receive the data back. So Geo helped us a little bit there. So now, yeah, so even Alexa has a
Like Alexa has a modem,
4G, yeah, it has an internet gateway, it has a 4G SIM card.
and that like the factory will figure out whether they want to do a SIM or because each country would have a separate system. Like that's not something you can do centrally, like bundling it with a SIM.
Yeah, so in UAE, for example, you gotta go through Etisalat or do So your provider changes, your pricing changes a little bit, right? There are certain compliances required in some geographies around that stuff, and whitelisting of IPs and whatnot.
And you ship it ready to communicate, or you ship it and the customer puts in a SIM and makes it ready to.
No. So the subscription for communication is also through us, right? So the customer is not taking care of that. So we are taking care of that. So we put a SIM in there and it's ready to go. So when it lands at a customer site, they just need to hook on power, hook on the communication cables, hook on the plumbing, and then grout it, meaning like anchor it to the floor, because with sufficient force, you can topple over an Elixir, right? So you just grout it to the floor and it's ready to go. That process today, it used to take us 2 to 3 weeks in the past. Today, it takes us 3-4 days. So that's how long the installation process takes.
Yeah. How did you crash it so much, like from 3-4 weeks to 3-4 days?
Yeah, by just looking at the different permutations and combinations of problems that we were facing, most of which had to do with just planning and customer readiness. So when we sign a contract, customer says, okay, blah, 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 this is what they're going to do in terms of data, in terms of power, in terms of communication and whatnot. And getting there and having all of those things ready to go is the most important thing in terms of how fast we go live. So if customer readiness is there, we can literally go live in a few hours. It's still very hard to get 100% customer readiness, right?
And you have like a plant in India which builds the Alexas?
Yeah, so we have a plant is a big word. So we have a plant just outside of Pune, about an hour drive from our office here. And what we do there is we do some wiring, soldering, right, and assembling of components, and a whole lot of testing, right? Yep.
That's more like a lab, I guess, then.
Yeah, I would call it like an assembly plant. It's like an assembly line where we are just putting together the Elixir. We pre-built them, but we might adjust the number of IOs, the types of sensors based on what we're shipping out. So the top section, which is the brain and the touch screen. So it's our design, but then we order them in bulk and we keep, because you can't order 5 boards at a time. You gotta order hundreds of these things at a time, and then because that's when the cost comes significantly lower. And then so we do some of our own sensors, and some of the sensors we buy. So even that is kind of stocked at a minimum inventory. We keep that, and then we just put this stuff together and a bunch of cables running between these things.
And so tell me about how your revenue works. Like what is the one-time cost you charge? What is the subscription? Like, help me understand the revenue model.
Yeah, see, the impact that Elixir makes is substantial, right? So we are talking about at least hundreds of thousands of, because these plants are producing almost millions of dollars of product every day. They're making hundreds of tons of steel or whatever they're making, right? So they're quite high revenue that they are producing. And even if Elixir has a very minor impact, right? Like even a 1% change or even 0.5% point change, that translates to a big impact for the customer. So at a minimum, we're talking about 6-figure savings, right? In a lot of cases, 7-figure savings to our customers, meaning hundreds of thousands of dollars to millions of dollars of savings, recurring savings every year. So it's substantial savings. And we take a very small fraction of that, but we end up monetizing tens to hundreds of thousands of dollars per year. So typically we sign a multi-year contract. So we don't do any kind of one-time, we don't charge our customers an installation fee, or we don't sell them the hardware, because the way Elixir works is a combination of what's in the device plus what's on the cloud. So the cloud is continuously communicating. There's a dashboard, there's data visualization, but there's also the AI getting updated from the cloud. So it's so the product is not just the physical product.
And you have SMEs also.
Yeah. So that's why we have built a commercial model in a recurring fashion, and the savings are also recurring. So depending on the size of the customer, and pricing is something that we haven't perfected. And I know we're leaving a lot of money on the table. We're giving, which is great. It's a great thing to do to create a lot of value for your customers. So so we end up monetizing something like $50,000 to $100,000 a year.
Got it. And what, like, for a customer, this is like what is the ROI? Like, if they're spending 100,000, how much do they typically save? Like,
at least 5 to 10x at a minimum, if not more. So we have some kind of saving sharing models where we bill our customer like a fixed monthly, we bill them a fixed amount of money every month, and then we calculate like the impact maybe once in a quarter, and then share, we get like anywhere between 5 to 15 to 30% of the savings.
so that's a pretty innovative pricing model. Yeah. So you have skin in the game basically to make the savings happen. Yeah, that's pretty.
Yeah, and customers are extremely happy to do that. And we are happy to do that as well, because we're confident in what the product can do, and also the sharing of savings is commercially better for us. It has always been. Yeah, so the customers get substantial savings, and what they pay for Elixir really a drop in the bucket for them compared to the savings. So they are, like I said, going back to our first installations, those customers are still our customers, and we continue to monetize the Elixir with them. So we rarely lose a customer because the product is so sticky. I hate comparing it to like a pacemaker, but it's like a pacemaker, right? Once you implant a pacemaker, you're not going to take it out. So similarly, once an Elixir is in the plant, it's very hard for the customer to take it or remove it, because they'd immediately lose the impact that Elixir is making. The only way that the customer could replicate it was to kind of replicate a product, which is not something that they would want to do. So,
But are there replacements out there, like another company which does the same thing?
yes. So everybody's now trying to get there. So if you think about us, so there's the kind of the data generation layer, right? Then you have the data acquisition layer, right? And then let's say the next one is the data kind of homogenization, data wrangling kind of layer, data visualization layer. And finally, you have the insights. And even after the insights, you have the intervention, right? So there are different people playing in different parts. So if you think about Elixir, it is comprehensive. It's doing most of these. It's not a piece of plant machinery, but it's doing everything else. It's generating data, it's homogenizing the data, it's analyzing it, visualizing it, generating insights of the data out of the data, and then using those insights to intervene. So there are people coming from, so for example, if you're a German pump manufacturer like Grundfos, very large German, they are making their pumps smarter and doing things like that. Right? If you are, so the things that we are controlling are finally the machinery in the plant, right? So those guys are making their equipment smarter, but the replacement cycles for these are like 20 years, 30 years. Because if you buy a piece of equipment for millions of dollars, you're going to run it for, multiple decades. So the replacement cycles are very high. So this allows us this opportunity to kind of plug the gap and use Elixir to make the plant smarter. So, and even today, if you were to go and buy equipment from one of these equipment vendors, they would have two versions. They would have the smart version and they would have the not so smart version. So it's like rear view cameras in cars, right? Earlier, you would only get them in like a Mercedes S-Class. Now they're kind of common, but even now they are an additional accessory. Not every car gives it to you as a standard feature. Now there are car companies that give it to you as a standard feature, but it takes time. It takes many decades for this to happen. And this gives somebody like a Haber the opportunity to go in and deliver this value because that gap exists. But everybody is coming into this space. So the software guys are now thinking about edge computing devices, so on and so forth. Even somebody like an Amazon, they're starting to provide like a vibration analysis layer, right? Now you had startups that came up with vibration analysis, right? So which means you put like a vibration sensor, which is translating noise or vibrations into like an electric signal, and then you use that to predict different things. So when is it going to fail? Do I need to change the lubricant? Is it time for maintenance? So on and so forth. Now startups did that. Then you have the people like SKF, the guys who make the bearings. Now they are doing it. So okay. Now you even have somebody like an Amazon who's coming from a different tangential angle, right? So there's many people getting into the space, and then you have the consultants, like the big four consultants are trying to do stuff. So yeah, it's noisy and chaotic. It's a bit confusing for customers, right? There's no clear cut competition, right? So it's not like, I want to purchase a laptop and these are the options, and you figure out the operating system, and then you figure out the brand. So there's no clear buying process. So it's a bit confusing for the customers right now, which is why we don't have, because our product is so good. In theory, we should have people lining up outside waiting for elixirs, but we don't have that. We have some inbound. I would say right now, 20 to 30% of our sales is inbound and interest, but still 70% is kind of push sales. And we're going out there and pushing elixirs. And that is something that needs to be, the cloud has to be cleared a little bit there so that customers understand and can compare and buy.
So like, what is the what's on your radar in terms of growth? See, right now, so let me like use a very simplified analogy. Like you had these desktops earlier, which could not get Wi-Fi signal. And so you had a dongle which you could plug into your desktop and make it Wi-Fi compatible. So right now Haber is somewhere there, but obviously not that simple, but like there's a lot more that you can plug in an Alexa and get smart capabilities. And then, like you said yourself, all of these manufacturers are eventually, maybe 20 years down the line, will have these as features. So what is where do you see Haber 20 years down the line?
See, we will turn into a platform, but more importantly, we're going to solve for sensors in a big way. Okay. So if you think about this all this technology that's getting built, but there's a lot of interesting things happening between data and using that data to do different things. For example, even we are doing some of this work, which is, can you use vibration data to predict the shape and size of an object and things like that. So there's a lot of interesting work happening there. But the creation of this data itself, right, has to start from the sensors. I don't see a lot of disruption happening there. And again, the barrier to entry in that space is also very high, right? Because you got to understand the problem and bring together different group of scientists from different disciplines to solve the problem. So I see it as having more kind of data generation capability, right? Meaning we have a lot of different advanced sensing capabilities, things like that.
So it could eventually also have a play like you have like Intel Inside when you buy a laptop. So that they could be like a Haber Inside, which let's say Siemens is selling a machine with Haber Inside. Like that could be like a long term.
Exactly. That Haber Inside thing is something that we have even discussed internally. We are yet to partner. So we have gotten a bunch of partnership offers, but we are yet to partner and test that out. So today we don't have any go-to-market partners. Everything is direct to customer. We touch the customer, our installation, everything we do ourselves. We sell ourselves, we install ourselves. We don't combine Elixir with any other product. It's standalone. So there are multiple discussions happening around partnership. Just a company that I named some time ago, we're talking to that company, a very large Swedish company that does, parts of the plant and other equipment manufacturers to kind of do this thing you're saying, Haber Insight. But we need the right kind of leverage. Right? Like this one conversation I had, it's like, okay, we're going to put Haber inside of our product, but we're going to call it ABC product, right? No, the customer's not going to know Haber's inside of it. So that's not something I'm very keen on. So we need to get sufficient leverage like an Intel has on the PC industry or the laptop industry.
Amazing. Okay. So essentially like a 2-3 decade roadmap would probably have very less hardware happening at Haber, and most of it being analytics, AI, and like more of that intelligence layer being done by Haber.
Yes. Yep.
Got
You
it.
know, like I was saying earlier, how do we take all the data coming from different elixirs and to have it all talk to each other, share insights, and then work in tandem, working together, right? Now sharing data, but they're not working together. So if we can get there, then we have taken this to a whole new level.
Or do you also want to do like vertical integration and actually go and acquire a company which is making these equipments themselves and then
The only kind of company I would be interested in acquiring would be like a unique sensor company that has solved a very unique way of measuring something, right? That earlier could only be done in a lab and now can be done in
got it.
real
Like
time.
backward integration side of it. Got it.
Because think about a smartphone, right? Now, a lot of things a smartphone can do is because of the sensors that exist in it. And either that ecosystem has to develop in my opinion, it's not moving as fast. So that is definitely something that we have started looking at ourselves, right? To solve for some of those sensor related problems. Meaning, how do you measure something in real time that can only be measured in a lab, those types of things. For example, going back to that example of brightness of pulp, how can you measure brightness of pulp in real time versus taking a sample and taking it to a lab and then understanding what the brightness is?
If you like the Founder Thesis podcast, then do check out our other shows on subjects like marketing, technology, career advice, books, and drama. Visit thepodium.in, that is thepodium.in, for a complete list of all our shows.